Hey, all right, so here we go. Again, talking about vectors. We're back into the journal now, so make sure you're checking your journal. This isn't, the vector thing isn't really huge, but just want you to understand what a vector is. A vector is not a ray. A ray is infinite. A vector is finite. It has an initial point and an ending point. It looks like a ray because it has that arrow up there, but it actually isn't a ray. It has a beginning at P and an ending at Q. When we write a vector, we write it specially. It doesn't get the full arrow. It only gets a half arrow, PQ. And the way we often indicate a vector, since it's going 5 units right, which would be +5, and 3 units up, which would be +3, we often indicate this as a vector of 5, 3, using the pointy brackets. Okay? Very important that we use the pointy ones here. They are not parentheses. They are not square brackets. They're pointy brackets that indicates it is a vector. Not going to be a whole lot on vectors here, but we're going to be using vectors quite a bit, because what we're going to be doing is we're going to be moving things in the coordinate plane. Let's just take a quick practice here with the vectors. One real quick question. Here's vector JK. We're going to name it JK with a vector, and we're going to write it in its component form. Ooh, that was not a very good pointy bracket, so let's try again. So this went right 1, 2, 3 because we start at J, right? We have an initial point. So right 3 and up 1, 2, 3, 4. So that'd be the vector 3, 4. JK has components 3, 4. Moves us right 3, up 4. Now, we're going to be dealing in this chapter with transformations. And you've dealt with transformations before. You've probably called them flips and twists and all sorts of things like that, slides and flips and twists. We're going to use their proper names now in geometry. We want to use the proper name for this. And this first one is a slide, but the proper name is a translation. A translation moves every point of a figure, whether that figure be a single point, a segment, a triangle, a quadrilateral. It moves every point the same direction, the same distance. In other words, it gets moved by a vector. Hence why we get a vector here. Okay? Now, the original point is always referred to as the pre-image. Okay? And let's say the original point's name was A, is called the pre-image. Okay? The new point, or the copy after the move, the new point after move, which I will call A primed. Notice you have that little apostrophe there. Okay, that's how, if you see that little apostrophe, A primed is what we call that. That's an indication that is a copy of the point after the movement. We call that the image. It's the image of the original. Okay, so there is some vocabulary here to deal with. Pre-image and image are pretty important words. So here I have point P is at some coordinate x1, y1, and the image of P, P primed, is at x1 plus A, y1 plus B, whatever A and B are. Because we're moving by a vector of A, B in this case. The second point of the segment, x1, x2, y2, goes to the image of Q, which is Q primed, x2 plus A, y2 plus B. Okay? Now, it does note that P to P primed and Q to Q primed are parallel lines. Okay? That's really not going to be super important to us, but it is kind of an interesting fact. They are definitely the same length. In practice, this is actually very simple. That all sounded really, really complicated, but in practice, this is really simple. Let's say I have the vertices of ABC are at 0, 3, 2, 4, and 1, 0. I need to translate that using the vector 5, -1. Well, first off, let's take a picture of this. Okay? If you do this graphically, this would be relatively straightforward. Okay? My point A would be at 0, 3. Okay. My point B would be at 2, 4. And my point C would be at 1, 0. So there's my triangle ABC. Okay? And I tell you, I want to translate it using the vector 5, 1. That means every x coordinate, we're going to go right 5 and up -1 or down 1. Okay? So to find A primed, I would go right 5 and down 1. And there is A primed. To find B primed, I would go right 5 and down 1. There's B primed. And to find C primed, I go right 5 and down 1. There's C primed. And we're going to get an exact copy of my original triangle just slid over. Okay? That's really easy to do from a picture standpoint. We're just sliding it over. That's a translation. Now, if I want to do it without the picture, it's just as easy. A, I said, was at 0, 3. My vector is 5, -1. So what do? 0 plus 5 is 5. 3 minus 1 is 2. So A primed is at 5, 2. Is that correct? Let's see. 1, 2, 3, 4, 5, 1, 2. That's where A primed went up. So B primed, just using coordinates, B was at 2, 4. We're going to move by the vector 5, -1. So 2 plus 5 is 7. 4 minus 1 is 3. C primed, C was at 1, 0. Moved by the vector. So 1 plus 5 is 6. 0 minus 1 is -1. And sure enough, that's exactly where all my coordinates wound up. So I can move and translate a triangle or any shape using the vector form or using the picture very, very easily. Okay? So what's the rule of translation here? Well, pretty simple. We just have to figure out how much it moved. So A was here, where I went right 1, 2, 3, 4, and down 1. So if I'm going right 4, down 1, my rule of translation will be 4, -1. That's all we got to do. Really simple. Okay? Now we can also write this instead of vector form using what's called component form. Component form is just another way of writing our vector. It's saying x, y goes to x plus some value, y plus some value. And of course, this is the amount right. If it's negative, of course, it's left. This is the amount up. If it's negative, it's down. Okay? So this would be the same thing as vector AB. It's a different way of writing it instead of vector AB. So the same translation here would be written as x, y goes to x plus 4, y minus 1. Some people like this second form, the component form, better because it's a little more descriptive as to what's going on. All right, simple on this page. Our translation is a rigid motion. A rigid motion is a motion that preserves all the qualities of the shape. None of the angles change, none of the sides change, none of the lengths change. Nothing changes except its position in the coordinate plane. Okay? That's what a rigid motion does. It creates a figure that's exactly an exact copy of the original figure in size and shape. It just might be flipped around or moved. In this case, translation just slides it over. The composition theorem says if we have more than one rigid motion, the composition remains rigid. In other words, this will become more important later when we get other rigid motions. Okay. So if we're given the rule for a translation as xy goes to x plus 1, y minus 2, find the image of point P at 3, 7. Well, first off, the image of point P would be P primed. And the coordinates of that point would be, well, 3 plus 1 is 4. And 7 minus 2 is 5. That's simple. Don't need to graph it, don't need to do anything. It's just right there. Sometimes, however, it asks me to go backwards. It said find the pre-image of the point V primed at 6, negative 5. The pre-image of V primed would be V. And what are we going to do for our coordinates? Well, we're going to go backwards, aren't we? If we start with the image and we go backwards to the pre-image, we're just going to do the opposite of whatever it says here. So instead of plus 1, we're going to go minus 1. 5. And instead of going minus 2, we're going to go plus 2. Negative 3. Okay? So if we're given the image and we want to find the pre-image, we just go backwards. That's pretty neat. That's pretty obvious and self-explanatory. How do matrices work with this? Well, because we talked about matrices for 2 days, we better bring that in. Basically, what we do is we create our coordinate matrix. Now, you remember doing this. We did this a couple of days ago. We have points A, B, and C here, and we have the x coordinates here and the y coordinates there. We've done this before to create an image matrix out, or a coordinate matrix out of a polygon. So we just take our points, put them into the matrix. Then what we do is we create a vector matrix, or a translation matrix. Our vector matrix is really simple. If our vector is negative 2, 3, we simply make our entire row 1 negative 2, and our entire row 2 is positive 3. And then we simply add the matrices. Okay? So with that translation, remember addition is easy. We just add the corresponding elements. So 3 minus 2, 3 plus negative 2 is 1. 0 minus 2 is negative 2. Negative 4 minus 2 is negative 6. Negative 5 plus 3 is negative 2. 2 plus 3 is 5. And 0 plus 3 is 3. And here are my points, A primed, B primed, C primed. I now have my coordinates. A primed is at 1, negative 2. B primed is at negative 2, 5. C primed is at negative 6, 3. So we can use matrices also to do our translation. And in fact, it's kind of nifty to do it with matrices because it works quick, it works easy, and it's just addition. Okay. So one more for you. Just one question today. You're getting off easy. It's a little longer podcast though. Let's have the points A, B, and C as I have triangle ABC, and the coordinate matrix for ABC is 2, negative 7, negative 5, 3, and negative 12, negative 8. Okay? And I want to translate that by vector. Vector. Make it pointy, not parentheses. Negative 6, 10. Find A primed. That's your question of the day. We'll see you in class.